Students, welcome to Sunil's tutorial. I'm Sunil Nirwani and today we'll be doing this chapter called as application of derivatives. Let's start, guys. Take down the sum, please. The edge of a cube measures 2 meters. The edge of a cube measures 2 meters. With a possible error of 0.5 centimeters. With a possible error of 0.5 centimeters. Find first part of the question, approximate error. Second part of the question, relative error. Third part of the question, percentage error in the surface area of the cube. Now let us assume that x and a denote the edge and the surface area of the cube. Now they've given me that the edge of the cube measures 2 meters and the possible error, this is how you write error, delta x. The error is 0.5 centimeters. Convert that into meters, 10 raised to minus 2 meters. First thing that you have to do is convert from centimeters to meters. Now they've said that find the approximate error in the surface area of the cube. Now the surface area of the cube we know is nothing but 6x square. Surface area of a cube is 6x square. Differentiate with respect to x. So d by dx of a is nothing but 12x. This can be written as dA is 12x dx. D can be written as delta, so delta A is 12x delta x. That means the error in A is 12x times the error in x. So delta A is 12, x you know is 2, error in x is 0.5 into 10 raised to minus 2. So this will be 12 into 10 raised to minus 2, which is 0.12 meters. Therefore the error in surface area of A is going to be nothing but 0.12 meters. Right? So this is my error in surface area. Is 0.12 meters. Next they've asked you to find out the relative error. Relative error is given by the formula error in A upon A. Right? Error in A you found out as 0.12. A is nothing but 6x square. And we know the value of x to be 2. So 0.12 upon 6 into 2 square, that is 4. Right? 6 ones are, 6 twos are, 1s are, 2s are. So that is going to be, when you solve this will come out to 0.005. Right? That is going to be my relative error in the measurement of area. Right? 0.005. And the last thing that they will ask you to find out is percentage error. Percentage error is relative error into 100. So that's 0.005 into 100. That's 0.5%. Right? That will be the error in the measurement of area. Next, take down another sum, guys. Find the approximate percentage error. Find the approximate percentage error in calculating the volume of a sphere. Find the approximate percentage error in calculating the volume of a sphere if an error of 2%, if an error of 2% is made in measuring its radius, if an error of 2% is made in measuring its radius, right? Let's assume that V and R denotes the volume and the radius of the sphere. Now they've given you that the approximate error in find the approximate error in calculating the volume of the sphere if 2% error is made in the measurement of radius. Error in radius is 2% of radius. This is given to you. Error in radius is 2% of radius. Now, volume of a sphere we know is given by the formula of 4 by 3 pi r cube, right? Differentiate with respect to r. So d by dr of V is nothing but d by dr of 4 by 3 pi r cube. So in which case I'll get dV by dr is going to be 4 by 3 pi, r cube can be written as 3r square. So in that case I can therefore say that dV is nothing but 3 and 3 gets cancelled, 4 pi r square into dr. D can be written as delta. So delta V is equal to 4 pi r square delta r. Right, do we get this thing here? Now delta r we have already found out as 4 pi r square. Delta r is nothing but 2% of r. Right? So now we know the value of delta V. Once I know the value of delta V, then I can find out the error, percentage error in volume. They've asked me to find out the percentage error in volume. So I can say that therefore percentage error in volume is nothing but delta V upon V into 100. Delta V you found out as 4 pi r square into 2 upon 100 r upon V, 4 by 3 pi r cube into 100. 100 gets cancelled, r cube gets cancelled, pi gets cancelled, 4 and 4 gets cancelled, denominator of denominator becomes numerator 6%. Right? Take down next sum please. The time period T, the time period capital T of a simple pendulum, the time period T of a simple pendulum, the time period T of a simple pendulum of length L is given by T is equal to 2 pi root of L by G. If there is a 0.004%, if there is a 0.004% error in the measurement of L, if there is a 0.004% error in the measurement of L, find the percentage error in T. Find the percentage error in T. Now, if we knew error in L is 0.004% of L, right? Now, T is given to you as 2 pi root of L by G. Differentiate with respect to L. So, d by dl of T is nothing but d by dl of 2 pi root L by root G. I'm just splitting the root sign up. constants come outside the derivative, so you will get d by dl of t is going to be 2 pi by root g is constant. D by dl of root l is 1 upon 2 root l. D by dx of root x is 1 upon 2 root x. So here 2 and 2 gets cancelled. So you will get dt is nothing but pi upon root g into root l into dl. D can be written as delta. So delta t is pi by root g into root l into delta l. But delta l we had already found out, or it's given to you in the sum. Delta t is pi by root g into root l into delta l is 0.004 upon 100 into l, right? Now root l and l gets cancelled to give you root l here, right? Once I know this, then I can find out percentage error in t. Percentage error in t is error in t upon t into 100. So that's going to be pi by root g into 0.004 upon 100 into root l upon 2 pi root l by root g into 100. 100 gets cancelled, pi gets cancelled, root g gone, root l gone, right? So in that case you will get this as 0.004 divided by 2 at 0.002%. Therefore the error in the calculation of t is going to be 0.002%. Next, take on next sum please. The total revenue R and the total cost C of a firm are given by R is equal to 380x minus x square and C is equal to 20x. Where x is the quantity. If there is a 0.5% error, in the measurement of the quantity, find the approximate error in the calculation of profit. Find the approximate error in the calculation of profit when quantity is 10 units. When the quantity is 10 units. In the find the approximate error in the calculation of profit when the quantity is 10 units. They've given me revenue, they've given me cost. I can say profit is nothing but revenue minus cost. That is nothing but 380x minus x square minus 20x, right? So in that case, this is going to be nothing but 380x. Yeah, you cannot do anything about it. So you got profit. Now they have said that you have to find out 360x minus x square. Next. Now, you have to find out the error in profit, right? Now I can say that P is equal to 360x minus x square, right? Differentiate with respect to x. So I'll get d by dx of t is d by dx of 360x minus x square, right? In which case you will get dp is equal to dp by dx is equal to 360 minus 2x, right? So you will get dp is equal to 360 minus 2x into dx. Dx can be written as delta x and dp can be written as delta p. So delta p is 360 minus 2x into delta x, but delta x is given to you as 0.5% of x. So delta p is 360 minus 2x into 0.5% of x. Fine, do we get this thing here? So in that case you will get this as delta p. If I take x inside, this will give me 360x minus, let's leave that as it is. Next, they've asked you to find out the error in the, find the consequent error in the calculation of profit. So we found out the error in profit if the number of units are 10. Now if x is equal to 10, I can say error in profit is 360 minus 2 into 10 into 0.5 upon 100 into 10, 0, 0, 1. I could take 10 common here, so this will be 36 minus 2 into 0.5 upon 10, 0, 0, 1, 34 into 0.5, which is nothing but 17. So the consequent error in the measurement of profit is going to be 17. Okay, so next let's move on to the next one, guys. Find values of x for which f of x is equal to x cube minus 9x square plus 24x is increasing, decreasing. Let's see this. They've given you the function f of x is x cube minus 9x square plus 24x. First thing that you do is differentiate with respect to x. So I'll get dy dx of f of x is equal to dy dx of x cube minus 9x square plus 24x. So you will get f bar of x, dy dx of f of x is nothing but f bar of x. So I can therefore say that f bar of x is nothing but 3x square minus 18x plus 24. Right? Now, this could be further simplified as 3x square minus 6x plus 8. Right? This could be further simplified as x minus 4 to the 8, 4 x minus 2. So I'll get f bar of x is 3 times x minus 4 x minus 2. Now coming to the first part of the question, f of x is increasing. I want the function to increase. Now when will the function increase? The function is increasing if the first order derivative is greater than 0. Any function will be an increasing function if the first order derivative is greater than 0, right? But we found out the value of f bar of x as 3 into x minus 4 x minus 2 is greater than 0. Take 3 on the other side, so you will get x minus 4 x minus 2 is greater than 0. When will the product of two numbers be greater than 0? The product of two numbers is greater than 0 when either both are positive or both are negative. So I can say either x minus 4 is greater than 0 and x minus 2 is greater than 0. Therefore, x is greater than 4 and x is greater than 2. Or x minus 4 is less than 0 and x minus 2 is less than 0. Therefore, x is less than 4 and x is less than 2. Right? So, these are the conditions in which the function would be increasing. Second part of the question, f of x is decreasing. When is a function decreasing? A function is decreasing if its first order derivative is less than 0. A function is decreasing if its first order derivative is less than 0. Right? First order derivative is 3x minus 4, x minus 2 is less than 0. Take 3 on the other side, so x minus 4, x minus 2 is less than 0. When will the product of two numbers be less than 0? When either one of them is negative. One is positive and the other is negative. So I can say either x minus 4 is greater than 0 and x minus 2 is less than 0, in which case x is greater than 4 and x is less than 2, which is not going to be possible. How can a number be greater than 4 and less than 2? Right? Or x minus 4 is less than 0 and x minus 2 is greater than 0. So therefore x is less than 4 and x is greater than 2. Therefore it will be a decreasing function when x is greater than 2 and less than 4. Fine, do we get this? How do we find out increasing and decreasing functions? Right? Next. F of x is equal to 2x cube minus 3x square minus 12x plus 12. Examine the function for maxima and minima. I want to find out what will be the maximum value of this function, what will be the minimum value of this function, right? F of x is 2x cube minus 3x square minus 12x plus 12. Just check whether I have copied the question correctly. 2x cube minus 3x square minus 12x plus 12. Now first thing that you need to do is differentiate with respect to x. So I'll get f bar of x is 3 to the 6 x square minus 3 to the 6x minus 12. d by dx of x cube is 3x square, d by dx of x square is 2x, d by dx of x is 1 and d by dx of constant is 0. Right? Now, I'll say but if you want to find the minimum and maximum value of a function, but for minima and maxima, a function can obtain minimum and maximum value when its first order derivative is equal to 0. A function can obtain minimum and maximum value when its first order derivative is 0. So it will have minimum and maximum value when f bar of x is equal to 0. But f bar of x we found out is 6x square minus 6x minus 12 is 0. Divide by 6, so I'll get x square minus x minus 2 is 0. Factor the x minus 2, x plus 1 is equal to 0. Either x is equal to 2 or x is equal to minus 1. Right? Now, this particular equation, f bar of x, let's label that as equation 1. Now, differentiate equation 1 with respect to x. So you get d by dx of f bar of x is d by dx of 6x square minus 6x minus 12. d by dx of f bar of x is nothing but f double bar of x. second order derivative of x, that is dy dx of 6x square will give you 12x minus 6. Let's call this as equation 2. Now we have found out that the two values of x are 2 and 1. When x is equal to 2, what will be f double bar of x? F double bar of x will be 12 into 2 minus 6, that's 24 minus 6, which is 18. We had found out two values of x. I have taken the first value of x. When x is equal to 2, f double bar of x is going to be 24 minus 6, which is 18, which is greater than 0. If you get the value of f double bar of x to be greater than 0, then the function is minimum. Therefore, I can say f of x will be minimum when x is equal to 2. Right? If the second order derivative is greater than 0, then the function will be minimum. Therefore, the minimum value will be, substitute the value of x, substitute this value of x in the original equation. To get the minimum value, substitute the value of x in the original equation. Fine? So if I substitute the value of x in the original equation, I will get 2 into 2 cube minus 3 into 2 square minus 12 into 2 plus 12. 8, 16, 4, 12, 24, 12. Minus 12 plus 12 gone. This is minus 8. So the minimum value of the function is going to be equal to minus 8. That was when x is 2. But we have also found out that x is minus 1. When x is minus 1, what will be f double bar of x? F double bar of x will be nothing but 12 into minus 1 minus 6 minus 12 minus 6 minus 18, which is less than 0. If it is less than 0, then the function is more. You learn it this way. Less is more, more is less. If you get f double bar of x to be more, then the function is less. If you get it as less, then the function is more. So I can say therefore f of x is maxima when x is equal to minus 1. Therefore, I can say that the maximum value of x will be, substitute this value of x in the original equation. Substitute the value of x in the original equation. So 2 into minus 1 the whole cube minus 3 into minus 1 the whole square minus 12 into minus 1 plus 12. Minus 1 the whole cube is minus 1. So minus 2. This is going to be minus 3 plus 12 plus 12. Minus 5 plus 24. 19. So the maximum value of this function is going to be 19. So the maximum value will be 19 and minimum value will be minus 8. Right? Take down another sum, please. The total cost C for producing X items, the total cost C for producing X items is given by x cube minus 300x square minus plus 12x. Find the value of x. Find the value of x for which the marginal cost is decreasing. Find the value of x for which the marginal cost is decreasing. Now first of all guys, what do we understand by marginal cost? marginal cost means the cost of producing one extra unit. Let's assume I have a factory that is producing 100 units. Now instead of 100 units, I want that factory to produce 101 unit. So to produce that one extra unit, the factory would incur some cost, and that cost is called as marginal cost. Fine. Now let's see this. They've given you the cost function. I'll say that differentiate with respect to x. So d by dx of c is d by dx of x cube minus 300x square plus 12x. So now rate of change of cost is nothing but your marginal cost. So marginal cost dc by dx is nothing but marginal cost. This is going to be 3x square minus 600x plus 12. But they have said that you want the marginal cost to decrease, right? So I can say I want my marginal cost to be decreasing. So I can say that marginal cost is decreasing. I have found marginal cost. I want it to decrease. So I'll differentiate this again. If I differentiate this again, I'll get d by dx of marginal cost is nothing but 6x minus 600, right? This is nothing but your first order derivative of marginal cost. This is nothing but your first order derivative of marginal cost. Huh? First order. This was marginal cost. Change in cost with respect to units is marginal cost. Now I'm differentiating this. So this is my first order derivative of marginal cost is 6x minus 600. For decreasing function, the first order derivative should be less than 0, right? That means 6x minus 600 should be less than 0, 6x should be less than 600, x should be less than 100. So the marginal cost will keep decreasing so long as you produce less than 100 units. Fine, do we get this thing clear? So the marginal cost decreases. I can say therefore marginal cost will decrease if x is greater than 0 and less than 100. Right? Take down another sum, guys. A rectangle has an area equal to 50. A rectangle has an area equal to 50. Show that a rectangle has an area equal to 50. Show that its perimeter will be least. Show that its perimeter will be least when it is a square. Show that its perimeter will be least when it is a square. Show that its perimeter will be least when it is a square. Right, let's assume that x, y, a and p denote length, breadth, area and perimeter of rectangle. Now they've given you that a rectangle has an area equal to 50. Area of the rectangle is given to you as 50. Now we know that area is nothing but length into breadth. Therefore breadth is nothing but 50 upon x. Right? Once I have this, then I can say that perimeter of the rectangle is given by the formula twice length plus breadth. Perimeter of a rectangle is given by the formula twice length plus breadth. So I can say P is equal to 2x plus y. Y can be written as 50 upon x. We have already found out the value of y to be 50 upon x, right? Now, they have asked you to make perimeter minimum. Show that the perimeter is least. whatever you want to make minimum or maximum, assume that to be f of x. So you will say let f of x be equal to 2x plus 50 upon x. Now solve this sum like a maxima minima sum. How do you do maxima minima? Differentiate, get two values of x and differentiate again. Right? So first thing I'll say differentiate with respect to x. So I'll get f bar of x is equal to 2 as it is. D by dx of x is 1 plus 50. D by dx of 1 upon x is nothing but minus 1 upon x square. D by dx of 1 upon x is nothing but minus 1 upon x square. Fine, do we get this thing here? Now, I can say but for maxima and minima, for maxima and minima we know that f bar of x should be equal to 0. That means 2, 1 minus 50 upon x square should be equal to 0. 1 minus 50 upon x square should be equal to 0. 1 is equal to 50 upon x square. X square is equal to 50. X is equal to plus minus 5 root 2. Right? Now, we will call the first order derivative equation to be equation 1. I'll say differentiate equation 1 with respect to x. So you will get d by dx of f bar of x is d by dx of 2, 1 minus 50 upon x square. So I'll get f double bar of x is 2 as it is. 1 is 0 minus 50 d by dx of x raised to minus 2. So this is going to be 2 as it is. D by dx of x raised to n is nothing but n x raised to n minus 1. So in that case you will get this as 2. 50 into 200 upon x cube. Right? So this is going to be 200 upon x cube. Now when x is equal to plus 5 root 2. If the value of x is plus 5 root 2, what will f double bar of x be? It will be 200 upon 5 root 2 the whole cube. Obviously this answer is going to be positive, right? Which I can definitely say is greater than 0. If f double bar of x is greater than 0, therefore I can say that f of x is minimum when x is 5 root 2. But what did we assume as f of x? The perimeter, right? Therefore I can say that perimeter is minimum Therefore, I can say that perimeter is minimum when x is equal to 5 root 2. Now, if x is 5 root 2, what will be the value of y? Y, we had assumed right in the beginning, is nothing but 50 upon 5 root 2. 50 upon x, so that's 50 upon 5 root 2. Therefore, y will be nothing but 5 root 2 again. 10 upon root 2, which is nothing but 5 root 2, right? I can say therefore x is equal to y is equal to 5 root 2. Now since x is equal to y, therefore I can say that the given rectangle is a square. Right? Two things you have to prove here. You have to prove that the perimeter is minimum. You prove that the perimeter is minimum. You have to prove that it is a square. You prove that it is a square. Right? Let's see another sum, guys. A box with square base. A box with square base and open top a box with square base and open top is to have a volume of 32 centimeter cube is to have a volume of 32 centimeter cube. Find its dimensions. If it is to be made, find its dimensions if it is to be made with minimum area of material. It is to be made with minimum area of material. It is to be made with minimum area of material. Let X, Y, A and B denote the length of the square base, height, area of the material, area and volume. Right, now guys, this box has a square base. That means if this is X, this length will also be X. The height is given to you as Y. Right? In that case, what will be the volume of the box? Volume is given to you as 32 centimeter cube. Volume will be nothing but length into breadth into height is 32. Therefore, Y is 32 upon X square. Right? Now, what will be the area of the material used to make the box? Now, guys, this is an open top box. First, let us make the base. The base is a square. Area of the base is going to be X square. Let's make the front face. The front face has length X and it has height Y. That means it's going to be a rectangle. So the front face is going to be a rectangle with length X and breadth Y. Similarly, if the front face is that way, the back face will also be a rectangle with length X and breadth Y. The side face, since it is a square, the length will be X and the breadth will be Y. The other side will also be the same. Therefore, to make the four sides, I need 4 times XY. It's an open top, so I don't need to make the lid for the box. Right? So, area of the material used to make the box is going to be X square plus 4XY. Right? They have said that find the dimensions if the area, if it is to be made with minimum area of material. Whatever they ask you to minimize or maximize, assume that to be f of x. So you will say let f of x be equal to x square plus 4xy. Right? In that case, differentiate with respect to x. So I'll get f bar of x is going to be 2x plus 4 uv formula. V derivative of u plus u derivative of v. Right? Now out of which I know the value of y. So I can say f bar of x is going to be 2x plus 4. Y can be written as 32 upon x square plus x d by dx of 32 upon x square. Right? This can be written as 2x plus 4 into 32 upon x square plus x 32 as it is, d by dx of x raised to minus 2. D by dx of x raised to n is n x raised to n minus 1. So this is 2x plus 4 32 upon x square plus 32 into minus 2. So that's minus 64 x upon x cube. Right? So in that case, x and cube gets cancelled. So you will get this as 2x plus 4 into minus 32 upon x square, 2x minus 128 upon x square. That is going to be my f bar of x, right? But for minima and maxima, f bar of x should be equal to 0. That means 2x minus 128 upon x square should be equal to 0, in which case I should say that 2x cube minus 128 is equal to 0. Common denominator x square goes on the other side to become 0. 2 common, x cube minus 64 is 0. X cube minus 64 is 0. X cube is equal to 64. X is equal to 4. Right? Now, your f bar of x, I'm going to call that equation as equation 1. So I'll say differentiate equation 1 with respect to x. If I differentiate equation 1 with respect to x, I'll get f double bar of x 2 minus 128 d by dx of x raised to minus 2 again. So this is going to be 2 minus 128 d by dx of x raised to n is n x raised to n minus 1. So this is going to be 2 minus into minus plus 256 upon x cube. Right? Now let's continue this here, guys. We've got f double bar of x as 2 plus 256 upon x cube, right? Once I have this, I'll say when x is equal to 4, f double bar of x will be 2 plus 256 upon 4 cube. Since there is no negative term involved here, this answer will obviously be greater than 0. So you will say as f double bar of x is greater than 0, therefore f of x is minimum when x is equal to 4. But what is f of x? You had assumed the area of the material used. Therefore, area of material used is minimum when x is 4. Now if x is 4, then I can say that y is given by the formula 32 upon x square. Therefore y will be 32 upon 4 square, 16, that is 2. Therefore the dimensions of the box are going to be, length is going to be 4 centimeters, breadth is 4 centimeters and height is 2 centimeters. Those will be your dimensions of the box. Right, next take on another sum, guys. That was the 9. Next, let's see the 10th sum. A sheet of paper has an area of 18 square meters. A sheet of paper has an area of 18 square meters. The margin at the top and the bottom is 75 centimeters. The margin at the top and bottom is 75 centimeters. And at the sides is 50 centimeters each. At the sides is 50 centimeters each. What are the dimensions? What are the dimensions if the area of the printed space is to be maximum? What are the dimensions if the area of the printed space is to be maximum? What are the dimensions if the area of the printed space is to be maximum? Let x, y and a denote the length, breadth and area of the paper. Now they give you that the area of the paper is 18 square meters. Area is nothing but length into breadth, so the 18, therefore I can say y is equal to 18 upon x, right? Length is x, breadth is y, right? In that case, what will be the they've said that, let us assume, let A1 be the area of the printed space. Right? Let's assume that A1 is the area of the printed space. Now guys, can you just look at the figure? The total length is x, out of which I am removing 50 centimeters from here, 50 centimeters from here. I am removing 100 centimeters. 100 centimeters is 1 meter. That means in terms of length, my printable area will be minus 1. Similarly, in terms of breadth, I am removing 75 centimeters from here, 75 centimeters from here. That means I am removing 150 centimeters. 150 centimeters is nothing but 1.5 meters. So this is going to be y minus 1.5. So the printable area is going to be x minus 1 into y minus 1.5. But we know the value of y to be 18 upon x minus 1.5, right? So in that case, if I expand this, this is going to be 18 minus 1.5x minus 18 upon x minus into minus 1 plus 1.5. That is going to be my printable area. But they are saying that printable area has to be maximum. Whatever they ask you to minimize or maximize, assume that to be f of x. So you will say let f of x be equal to 18 minus 1.5x minus 18 upon x plus 1.5. Now differentiate this with respect to x. So I'll get f bar of x is 0 minus 1.5 minus 18. D by dx of 1 upon x is minus 1 upon x square plus 0. So f bar of x is going to be nothing but 18 upon x square minus 1.5. But for maxima and minima, f bar of x should be equal to 0, right? Therefore I can say that 18 upon x square minus 1.5 should be equal to 0, in which case I can say that in which case I can say that 18 upon x square is equal to 1.5. 18 upon 1.5 is equal to x square. So which you will get as x square, you will get this as 12. Therefore x is 4 3s are 2 root 3 plus minus. You will get the value of x as plus minus 2 root 3. Now differentiate equation 1 with respect to x. What is equation 1? The equation where you have got f bar of x. What was your f bar of x equation? It was f bar of x equation was 18 upon x square minus 1.5. Differentiate this. So if I differentiate this, I'll get dy dx of f bar of x is dy dx of 18 upon x square minus 1.5. So f double bar of x is going to be 18 as it is. Dy dx of x raised to n is n x raised to n minus 1 minus 0. So that is going to be minus 36 upon x cube when x is equal to 2 root 3. When x is equal to 2 root 3, f double bar of x will be minus 36 upon 2 root 3 the whole cube. Right? Now this number, since it has a negative sign, obviously is going to be less than 0. Right? So I'll say as f double bar of x is less than 0, therefore f of x is maximum when x is equal to 2 root 3. But what is f of x? We had assumed the printable area to be f of x. Therefore I can say that printable area is maximum when x is equal to 2 root 3. So the first thing that you have to prove was that the printable area is maximum. Now once I know x, I should be able to get the value of y. Y is nothing but 18 upon x, which is nothing but 18 upon 2 root 3, 9, 3 root 3. Therefore the dimensions of the paper should be x is 2 root 3 meters and 3 root 3 meters. So the length should be 2 root 3 meters and the breadth should be 3 root 3 meters. Fine, do we get this thing here? Okay, we'll stop this here for the day. Thank you very much.